we got the relationship between the IB and the IC, right? So IC is some constant where we call it HFI multiply with IB. Okay, so that is the relationship between this one. Okay, and what is the HFI? Another parameter, another constant. Okay, let's say the constant, and we read it on the data sheet of the transistor. Okay, and the last operation mode, the last operation area of the transistor would be this straight line here. Okay, okay, this one. All right, this area, only the straight line here. So we call it the saturation mode. Okay, so that there is no not enough space, so I write it very short. Okay, just a review. In saturation mode, we can see that VCE keep constant. No matter what the operation point here, we point to the horizontal line or horizontal axis, the VCE axis, we will see the same result, right? We point it and then we see the same result. And that same result, that's constant. We call it the VCE saturation, okay? VCE saturation, where we have VCE, okay, equal to VCE saturation, okay, and this one is a constant, and we can find it, we can have it on the datasheet of the transistor. Okay, so every time you see the transistor, it will operate in one of the following, one and only one of the following. Okay, which one they don't say, it depends on the case, but just only one of the following. Okay, and your job, your analysis need to make assumptions for what the operation mode the transistor working in. All right, so let's review by a example, right? Let's see on you can do it or not, right? So I applied it here. This one for RB, right? And I got here, and I got here. Okay, and I got here. VCC, all right, it's called VBB, right? And then RC, and then RE, okay? And this one is VEE, all right. So Q is our transistor. And the data is like this, RB, okay, I give it RB for 33 kilo ohms, okay. RC is um, RC is 1 kilo ohms, okay, and then RE is 1 kilo ohms, okay. Sorry, let's say 500 ohms, okay, and VBB 6 volt, VCC, okay, sorry, VCC is 12, okay, and VEE is minus 1 volt, okay, let's say it's minus 1 volt, and then Q, okay, have HFI, right, is around 60 or 50. VBE, okay, actually it's called it VBE on, all right, is 1.2 volt, and VCE saturation, okay, is 0.4 volt, okay, and that is it. Let's see, where's my eraser? Okay, put the volt here. And can you find the powers dissipated by transistor? Okay, cool. Okay, power dissipated by the transistor. You have 5 minutes to do. If you have the result, please put it in the in-call message for me. Okay. Để mà ôn lại cái bài hôm trước thì mình đã review cái hoạt động của con transistor theo 3 cái miền hoạt động. Rồi mình giải thích cái 3 cái miền hoạt động đó. Thì bây giờ mấy bạn xem thử coi mình làm thử cái bài tập này coi xem cái tuần trước mình đã giải thích vậy rồi mình còn nhớ cái gì hay không. Chúng ta làm giúp thầy cái bài này thử. Số liệu nào mà chưa có thì mình báo để thầy cung cấp thêm. Hãy tính công suất của con transistor này. Alo alo.
Dạ nghe này.
Ok không mấy bạn? Rồi đâu mấy bạn làm thử cho mình xem thử. Ra chưa mấy em?
Mặc cái áo chưa? Áo đâu mà không dám mặc?
Bạn nào làm ra đáp số bao nhiêu cái phần công suất á, bạn nhắn lên cái cửa sổ chat giùm mình cái. Alo, sao lâu vậy? Alo, anyone? Các bạn nào làm ra kết quả chưa? Lâu vậy ta. Alo, sao không thấy ai nhắn kết quả hết trơn trời? Alo, bạn nào làm ra nhắn lên cho thầy xem. Đâu rồi? Lâu vậy? Năm 55.6. Này là watt hay là miliwatt em? 55.6 watt. Sai rồi, còn bạn nào khác nữa không? Còn bạn nào khác nữa không mấy bạn? Alo. Này 2.34 miliwatt hả? Ok. Mình check thử coi nha. Còn mấy bạn khác thì sao rồi? Đâu mất tiêu hết rồi. 31 người luôn mà. Bữa sau chắc phải đi kiểm tra đầu buổi và kiểm tra cuối buổi gì quá. Cho bài kiểm tra nhẹ nhẹ quá. 37.39 mW. Ok. Let's do it. Okay. Okay, before we start, we have to put the symbol, right? Like IB. Okay, we put the currents into the circuits, right? IB for these directions, and then IC for this direction, and then IE for this direction. Okay, so the incoming equal to the outgoing. Consider the transistor Q have the incoming for IB and IC, and the outgoing is for IE. So we have the first equation should be IB equal no plus IC equal IE. So our first equations. Okay. The second equations we draw a line. Okay. We apply the KVL, the Kirchhoff voltage law, where we have the voltage drop for VBB minus VEE, okay, equal to the drop of the elements on the way of traveling, okay. The total drop of all elements on the ways of traveling. Where we have here the voltage drop for RB, it should be following the Ohm's law. We have IB multiplied with RB. We have IB multiplied with RB, okay? And then the voltage drop from here to there is mean from B to E, all right? So that is the VB to E of the transistor, okay, of the Q. So for the Q, just only one Q. I don't need to write it down. Okay, and then the voltage drop for RE, right? That is followed by the Ohm's law, IE multiplied with RE. Okay, IE multiplied with RE. Okay, and then we have the other KVL, Kirchhoff voltage law from VCC to VEE. Okay, VCC minus VEE equal, right? ICRC, and then from C to E, okay, and then RE, IE, RE, okay, and that is it. That is our three equation, but we have the four variables. The first one is IB, and then IC, and then IE, and then another VCE. Because we have VBE, right? We have VBE here. Where is it? VBE is here. We got a VBE already. All right. So we have four variables with only three equations. We need one more equations, right? That is, we have to make assumption, right? These are the two. One, two, three. Okay. Then we have to make the assumption for. Okay. Assumes BGT operate, okay, in, so what kind of mode do you like? Okay, just make an assumption, so we don't need to very be precise. So I would like to make it saturation, for example. Saturation mode. Okay, saturation mode. Where if we assume this, we would have the VCE as the constant. Okay, equal to VCE saturation. Okay, and then we have the value for saturation is 0.4. Okay, 0.4 volt. And then we got the fourth, okay, equation. Then we solve the equations here for the result. Okay, let's say okay, let's say, let's see. Okay, so what is ours? I put the numbers in. VBB minus here should be 6 minus of minus 1. Okay, equal to IB RB. What is RB? 33 IB. Okay, and then plus VBE for 1.2. Okay, 1.2 volt. 1.2 volt. And then IE RE, right? IE RE. RE is 0.5 kilo ohms. Okay, 0.5 kilo ohm for IE. IE is I would like to make it as the first equations. We got the IE equal to IB plus IC. So IB plus IC. Okay. All right. And then we have the two variables equations like 33.5 IB. Okay. Plus 0.5 IC. Okay. Equal 7 minus 1.2, right? 7 minus 1.2 is 6, 5.8 or something. Let me double check it. Okay, 7 minus 1.2. Okay, all right, 5.8. Okay, and then from the question number 4, we have the VCC minus VEE, right? VCC, where is it? VCC here, 12, right? Minus VE minus 1, no, minus of minus 1, okay, equal to ICRC. What is RC? RC values, 1 kilo ohms, okay? 1 kilo ohms IC, all right? And then VCE is 0.4, okay? And then IERE plus 0.5, and then IB, IC, okay? And then I have my equation like IC with another 0.5 is 1.5 IC plus 0.5 IB, okay? Equal to 13 minus 0.4 is 12.6, right? And then I get two equations for two variables. I open my calculators and then 5, okay, 1, okay, I put the parameter in 33.5, okay, 0.5 and 5.8, 1.5. No, remember the IB is the first column row, so got the wrong one, right? 0.5, 1.5, and 12.6. All right, double checks, and you got the result. So I got my IB, okay, should be 0.048 milliampere. Okay, remember I put the values for the unit for kilo ohms, and then I got my result as milliampere. All right, and the next result should be 8.384. I see for 8.384 milliampere. Okay, and then we have to check for this result is acceptable or not. Okay, remember we make the assumptions for the operation of the transistor at the saturations, where remember in the saturations here, okay, saturation mode here. Okay, I might redraw it right here for you to check. Okay, if you don't remember, you can redraw this one, create this one, VCE, IE. Okay, so this is our operation. Okay, just the line like this. Okay, so if we have the operation in here, right, where one IC, okay, IC, okay, infer from the line, right, from one point here, we infer to the IC columns, you got the values, okay, and then it's move up and down, right, from zero, right, from zero to the maximum values right here, right. The maximum value is the correct is the amplifying mode IC, okay, according to IB something here, right, IB equals something here. All right, so the maximum values for amplifying mode of the IC should be HFI multiplied with IB. So IC will operate from zeros to maximum of HFI multiplied with IB. So the conditions, okay, conditions for saturation mode, okay, would be IC less than, okay, it's not equal, less than HFI multiplied with IB. Okay, so let's check this one's HFI and compare with our IC here. Multiply with IB should be what? Okay, so where is it? HFI is 50. Okay, so we take the no mode 1. Okay, 0.048 multiply with 50. Okay, and this is the 2.4. Okay, milliampere. All right, so this IC is greater than 2.4 milliampere. So the assumptions for BJT operate in saturation mode is not correct, right? Because we not get this one conditions. All right, so the assumptions is not correct. Okay, then we make a new assumption. Okay, new assumption. Okay, amplified mode in short. Okay, amplified mode. Well, if we got amplified mode, we will have the IC equal to HFI multiplied with IB, right? We got this one, and we have to do it again from here. All right, so IE is IB plus IC, right? So we got HFI and then 1 plus HFI, right? Multiply with IB. Okay, so we replace the equations here into the equations number 2 and equation number 3 to get the result. So we put it here. It is 6 minus 1. Okay, sorry, equal to what? RB is 33. Okay, and then VBE is 1.2. Okay, and then RE for IE I got okay 1 plus SFI for 50 IB. Okay, and then RE for 0.5. Okay, and then I got my result for IB. Okay, and I got my result for IB. So I open my calculator to do it. So this one is 33. Take the plus with 50. Okay, no, 51 divided by 2. Okay, multiply with 0.5 is divided by 2. Okay, and that is our IB. Okay, that is our IB parameters multiply, and then I got my 7. No, I got my 80. 58.5. Okay, I got my so 5.8, right? It's 7 minus 1.2 is the 5.8. Okay, and then divided by the last answer. Okay, and then I got my result for 0.099. I can say is 0.1 milliampere. Okay, 0.1 milliampere. Okay, and then I have my what? My IC. Okay, multiplication to 50, right? 50. Okay, and then I got my 50. Okay, 5 milliampere. Okay. All right, and we have to check for the assumption if you like. Okay, of course in this case we can sure that BJT will apply will operate in amplifying mode, but if you would like to check, this is the areas for the amplifying mode. Okay, so it would have the stable or the constant HFI multiplied with IB is IC here. But the VCEs, okay, you take one point here, you infer to the VCE axis, you will see that it's the point here. So you moving forward and backward, you will see the limitations would be the minimums for this is VCE, right? Saturations. Okay, so VCE here. It would be greater than VCE saturation. So the conditions for amplifying mode, right? So take here conditions for amplifying mode. This one is long right. Is okay. VCE greater than VCE saturation. All right, then let's check. So from here I can have my VCE, right? VCE, I have to calculate my VCE right here. Okay, so it would be 12, right? And then sorry, and then minus of minus 1, right? minus of -1 right here, and RC IC. So minus RC for 1, IC for 5, okay, and then minus IE RE, okay, and then minus, okay, 51 SFI plus 1 multiply with IB 0.1 multiply with RC 0.5, okay, and what is the value? Okay, we have to check. In our case, this one is 0.4, all right, so let me check it. 12 minus -1 is mean +1, and then minus 5, and then minus 51 multiply with 0.1 multiply with 0.5, okay, and then we got 5.45 volt, okay, and this one VC is 5.45 greater than 0.4 volt, okay, so this is correct, right? This is correct. Where is it? Where is here? Okay, so this is correct. So ours working mode for the transistor would be amplifying mode. Okay, of course, if you make the assumption for the saturation mode and you get the wrong results, you got the not fixed, not right condition for saturation mode, then you can sure that the transistor will work for amplifying mode, because it's only 3 modes the transistor can operate, and the cutoff modes normally when we have the VBB, you will see that there would be some IB, okay, some value for IB, and then if we have the IB is not 0, then it would operating in either saturations or amplifier mode. Okay, so now we took the calculation. We take the calculation for the power dissipated by the transistor. Okay, so let's say need to erase it a little bit. No. Oh man. Okay, so our power dissipated by the transistor P of the quill. Okay, so it's from IB VBE plus IC VCE. Okay, and then you got the result 0.1 multiply with VBE is for 1.2 plus IC is 5 multiplied with 5.45. Okay, and it is close to the result. It's not the right result. So 0.1 multiplied with 1.2 plus 5 multiplied with 5.45. Okay, okay, and it is the 27.37 milliwatt. Okay, okay, am I right or not? So you are on wrong, man. So let me put the exact value for 1.9 divide by 33 plus 51 multiply with 0.5. Okay, and then I okay, multiply with 1.2 plus, okay, multiply with the VCE. Okay, I have to get the VCEs for, oh man, for 12, no, 13. I want to be the exact value, all right? Minus 50 multiplied with n's, okay, and then minus 51 multiplied with 0.5, multiply with n's, okay, and close the bracket. Okay, and then I got, so the exact value should be 27, right, 4, right, 5 6 milliwatt. Okay, 6 milliwatt. All right, so you got wrong value. Oh man, vậy là các bạn làm sai hết rồi hả bạn? Alo, sao kỳ vậy? Oh man, rớt hết rồi. Chất quất hết. Được rồi, để tôi cho thêm bài nữa giống y hệt vậy coi làm được không nha. Okay, let's do it again. I got the VBB, VCC, and the circuits like that. Okay, with all the values we have. All right, and then please calculate the power dissipated by the coil, the transistor coil. Okay, 5 minutes, and then let's check. Để coi coi lần này bạn nào rớt, bạn nào đậu nha.